Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, the chemistry faculty from Infinity Learn. And I hope I'm perfectly audible. So those who are watching the session, just mark your attendance here so that I can understand. Okay. Here we will be continuing with the NCERT exercise, right? NCERT solutions for the different chapters. So we have already completed our first 3 chapters, chemical reactions and equations, acid, base and salts, and the third chapter, metals and non-metals, right? So here today we are going to discuss some of the very important questions or some of the very important questions from the chapter carbon and its compounds from the NCERT solutions. Hi Nandita, good evening, welcome to the session. So we have already completed the chapter, right? So what are the important topics we have studied in the chapter? Carbon and its compounds. Simply it is about the carbon, right? Carbon is an element which is having a tetravalency. Nandita, I have already completed the lecture for the chapter carbon and its compounds. You can watch our recorded session in the channel. I have already completed the complete lectures by 7 parts, I think. Then we have taken already the one-shot revision video for the same chapter also. You can just rewatch the session. So carbon, right? Carbon, it's about the carbon. Carbon we have already studied. They have the catenation property. They have the versatile nature is there, right? That's why they are forming different compounds because of their catenation property. Then what we have discussed about the carbon compounds like ethanol and ethanoic acid. We have seen the nomenclature, isomerism of the carbon compounds, right? So we can quickly start our first question from the NCERT solutions. Okay, here is the first question in your textbook. It's only about the NCERT exercise for the chapter carbon and its compounds. You can see there is 15 questions are there. I have taken around 12 or 13 questions from the exercise. So what about the answer for this question? Ethane with the molecular formula C2H6 has how many covalent bonds are there in the case of this compound? So we have already idea about the ionic compounds and the covalent compounds, right? Especially the carbon will be forming the covalent compounds because of the sharing of electrons. They have the tetravalency, right? So here you need to identify the structure of the C2H6 molecule, I mean ethane molecule, and identify how much covalent bonds are present there. Hi Arush, good evening. So options are provided here, right? So just let me know what is the answer. I hope I'm audible, right? Is there any issue? Manraj? So just try to write down the structure of C2H6 molecule, right? We know that C2H6 molecule means that is our ethane compound, right? In which I hope you can idea about this compound, right? These are the ethane compound with the single bonds, or it is an hydrocarbon, right? So each bond is formed by the covalent bonds. These are the covalent bonds. They are formed by the sharing of electrons. If you have idea about the electron dot structures, you will get a proper idea, right? So how many bonds are present here? 1, 2, 3, 4, 5, 6, 7, right? In me, which means total 7 covalent bonds are present in the case of C2H6 molecule. So option B will be the correct answer. Harish, this is our first question. You need to identify the number of covalent bonds in the case of C2H6 molecule. I hope you understand the question and answer, right? C2H6 molecule, as we already know, this is a hydrocarbon in which single bonds are present, right? 2 carbon compound in which all the bonds are covalent in nature, which means formed by the sharing of electrons. So I will try to draw the electronic structure over here. So what about the valency of carbon? It will be 4, right? So let us say here it will be 4. Then second carbon is again having the valency of 4. So this cross mark will be represented electrons in the case of carbon, I mean valence electrons in the case of carbon. Now what about the case of hydrogen? Okay, let's take it. Maybe you have idea about the okay, I will try to increase my volume. Hi Meena, good evening. So here this is the electron dot structure of the molecule, right? So we can say that completely this will be forming the so they will be formed by the sharing of electrons. So it will be forming one bond over here. This is again one bond, this is again one bond, this is again one bond. So which means all of these bonds are covalent in nature. I hope you understand. We have already discussed about the electron dot structure of different molecules. Is there any confusion? So this is the line structure, this is the electron dot structure, right? So what we need to do, you need to identify the molecule C2H6, right? C2H6 means they will be containing 2 carbon atoms. So first draw the 2 carbon atoms over here, right? Then this is C2H6, as we already know, this is the alkane or the saturated hydrocarbon, which means there is only single bonds are present. Okay. Single bonds are present, so here it is, one single bond is present here. Then we know that in the case of carbon, valence is 4, right? So remaining 3 are balanced by the 3 hydrogen atoms. Here it is again balanced by 3 hydrogen atoms. So that's why we can draw the line structure of C2H6. Harish, I hope you understand now how to draw the line structure of different molecules. Is that clear? Can we move to the next question? Yes, these are only the bond line structures. I hope you understand. So let's discuss detail when we are discussing about the unsaturated hydrocarbons, right? Okay, now we are moving to the next question. I hope it is clear for everyone. Then, here is the next question. Butanol is a 4-carbon compound with the functional group. We have discussed many functional groups like carboxylic acid, aldehyde, ketone and alcohol, right? We have already discussed about the IUPAC naming of the different functional groups, right? So here a compound is given with a 4-carbon compound having the name butanol. You need to identify the functional group present in the particular compound. What will be the answer? So I hope you got the answer as option C, right? That is, it is a ketone compound. We know that ketone compound means they will be having the functional group of C double bond O, right? C double bond O. So how we can draw the structure of this butanol? Butanol means it will be 4-carbon compound, right? We know that if carbon number is equal to 4, that word root will be equal to but, right? So we will be starting, we will be write down the 4-carbon over here. So this will be the structure, I mean this will be the structure of the butane compound. Then valency will be satisfied with the remaining hydrogen atoms, right? It's already balanced here. Here it is H. So this is the line structure of the compound, and if you are drawing the condensed formula, it will be CH3, CH2, C double bond O, CH3. Butanol. ONE stands for the ketone functional group. Is that clear? Yes, it is ketone because the suffix is ONE. Then what about the suffix for the carboxylic acid? Anyone? Carboxylic acid means same, right? Oic acid will be the suffix over here. Then aldehyde, it will be Al, right? Alkanal. What about the case of alcohol? It is OL, right? Like butanol, propanol and so on. Clear? Is there any doubt? This is about the IUPAC naming of the different functional groups. Okay, carboxylic acid means COOH and their suffix will be oic acid. I hope you understand. Then aldehyde, it will be CHO, right? CHO. And alcohol, it is OH group, hydroxy group. Yes. Now we are moving to the next question. While cooking, if the bottom of the vessel is getting blackened on the outside, it means that whether it is completely, if the food is completely cooked or it is not burning completely, or if the fuel is wet or the fuel is burning completely. Yes, option B is the correct answer, right? The fuel is not burning completely. That will be giving the incomplete combustion, right? That will be giving a black color over the vessel. Direct question, right? Then here is the next question. Okay, it's a statement type question. I have already given the answer here. What is homologous series and explain with an example? So direct statement question, right? What do you mean by homologous series and give an example. So what do you mean by homologous series? I have given a brief paragraph over here. You can find out the major points over here and give it according to the answer. I mean, give the answer according to the marks. Especially you can expect the question in terms of 2 marks question. As difference of CH2 molecule, I mean CH2 unit, right? Or we can define the series as a series of compounds with same functional group, right? These are the compounds with same functional group have a difference in CH2 molecular unit, right? So this also contains similar general formula and chemical properties. Similar general formula and chemical properties, but there is a difference in the physical properties. Why? Because there is a change in the molecular size and the mass, because they are differed by the CH2 unit. So can you please give me an example? For example, if I am asking about the homologous series of alkanes, what will be the first 3 members in the homologous series of alkanes? Alkanes, saturated hydrocarbons, only single bonds are present. So first you need to identify the first member of the alkane. That will be our methane, right? So I have already mentioned here, in the case of homologous series of alkenes, first one is methane, right? Methane means CH4. Then what about this next compound? Ethane. Ethane means C2H6, right? Then propane means C3H8. So what is the difference over here? Every successive compound will be having a difference of CH2 unit. I hope you understand. Is there any confusion? Arush, what is the general formula of alkanes? It is CnH2n plus 2, right? If your carbon number is 2, obviously hydrogen number will be 2n plus 2. That is 2 into 2, 4 plus 2, that is equal to 6. Is that clear about the homologous series? Similarly, you can find out the homologous series of any of the functional group like ketone, alcohols and aldehydes and so on. Is that clear? Is there any doubt? Arish, where did you got this question? So there is a mistake in the name of that compound. Your name of the compound will be 2,2-dimethyl-butane, not dimethyl-butane 2,2, right? We need to mention the position of substituents in front of the compound. I mean, give the number first before giving the name, right? So 2,2-dimethyl-butane will be the name of that compound, not dimethyl-butane 2,2. I hope you understand. So we can draw the structure over here. Okay, let's complete this question, then I will explain the structure of those molecules, right? Here is the next question, direct question. Why are carbon and its compounds used as fuel for most applications? What is the property of carbon and its compounds? Just give me a single word about the carbon and its compounds used as a fuel. Already answer is provided here, right? Carbon will bonds with the burns in oxygen to form carbon dioxide gas that will be easily act as a fuel. For example, if you are taking any of the hydrocarbons, right? So let's take an example of methane. Methane is the constituent of the natural gas. This is again carbon compound, right? Then what about the next one? Propane and butane. Maybe you have studied in the case of LPG, liquid petroleum gas, which is used in our home purposes, right? So in that case, they will be used as a fuel. This is again hydrocarbons, right? So what is the nature of the carbon compounds? Carbon burns in oxygen or air to form carbon dioxide gas, and this reaction is exothermic in nature, that is heat releasing, right? So that's why they are used as the fuels. Is that clear? Yes, these are the applications, right? Okay, fine. Okay. The next part is about the soaps and detergents, right? We have already discussed about the reaction of soaps and detergent. Explain the formation of scum when hard water is treated with soap. I hope you understand the question. I have given a related equation over here. Explain the formation of scum when hard water is treated with soap. So just think about the composition of the hard water. What is the chemical behavior in the case of hard water? Is there any salts are present? Whenever they are treating with the soap, what they are forming? What is the nature of hard water? Whether it is giving lather with soap or not? Okay, as you can see over here, right, hard water always containing calcium or magnesium salts of compound, right? So calcium or magnesium salt will be present. So we know that in the case of soap, these are the sodium or potassium salt of the long fatty acid, right? So this is the chemical formula of the soap we can represent over here, RCONA. Whenever this is come in contact with the hard water, the Ca2 plus ion or the Mg2 plus ion present in the hard water will combine together to form a precipitate over here. Here it is the calcium precipitate, here it will be the magnesium precipitate, and these precipitates are commonly known as the scum. I hope you understand. In words we can express here, soap is basically sodium or potassium salt of higher fatty acid. Hard water contains it calcium 2 plus and magnesium 2 plus ions as a salt. When soap is added to hard water, the corresponding calcium and magnesium salts are formed over here, as you can see over here, right? So this precipitate is known as the scum. Is that clear? Is there any confusion? This is about the case of soap formation. Soap is the longest carbon chain of the fatty acid. Sodium and potassium salt of the fatty acid. Okay, I hope it is clear. Now, what change will you observe if you test soap with litmus paper? Next question. You are taking red litmus as well as the blue litmus paper. What is the color change over there if you are taking the soap with the litmus paper? So identify the nature of soap, whether it is acidic or basic, then identify whether they are changing blue litmus to red or red litmus to blue. Okay, what will be the answer? It's already mentioned here, right? So when soap is dissolved in water, it is alkali in nature or basic in nature. So the basis will be easily changes to red litmus to blue, right? Red to blue is basic. And blue to red is acidic. We have already discussed in our third chapter acid, base and salt along with the litmus paper, right? Is that clear? So if you are taking the soap, we'll be treating with the litmus paper like red or blue. Red will be changed to blue, and for the blue litmus there is no any change because it is basic in nature. Is that clear? Okay, I hope it is clear. Now, here is the next question. What is hydrogenation and what is its industrial application? What do you mean by the process of hydrogenation and what is its industrial application? Okay, the emulsifying action of soap on dirt, maybe you have studied in the case of micellar formation, right? So in the case of soap, let's say here, so soap can be represented as, I hope it is visible, right? So the longest fatty acid, right? So this is a part of the soap molecule. So this is the hydrophilic part, right? Hydrophilic part means water loving part. And this is the hydrophobic tail. Maybe you have studied about the action of soap on dirt, hydrophobic tail, right? So this way we can represent the soap molecule. Soap molecule will be containing hydrophilic head as well as the hydrophobic tail. Hydrophilic means they are water loving, right? So we know that if there is any dirt containing as the oil particle, what they are forming, these soap particle will be combined together over here. My drawing is not that much perfect, so you can just refer from the NCERT textbook, right? So here it will be dirt particle will be present. So what they are forming? This is the hydrophobic tail, right? So this hydrophobic tail means water. This is not loving by the water, so this will be just attracted to the dirt particle. So they will be forming a circle-like structure is known as the micellar formation. So whenever they are asking about the emulsifying action of the soap over there, you can represent in terms of the micellar formation, right? I mean the cleaning action of the soap with water. Is that clear? Am I audible? Is there any issue? Okay, I hope it is clear. Now let's come to this question, hydrogenation, right? So hydrogenation means addition of hydrogen, right? So as water fairing is dirt loving part, hydrophobic tail. Voice is low. Okay, fine. I hope it is audible now. So this is about the application of hydrogenation, right? Application of hydrogenation. As you can see over here, whenever the vegetable oil like unsaturated oil added the hydrogen in presence of catalyst like nickel or palladium, that will be changes to vegetable ghee. Vegetable ghee means that is the saturated fat, right? So hydrogenation is the, okay, fine. Hydrogenation is the process of addition of hydrogen to the unsaturated hydrocarbon. Unsaturated hydrocarbon means that will be containing either double bond or triple bond, right? In the presence of catalyst like nickel or platinum or palladium, that will be converting to saturated hydrocarbons. Main example of the application is the conversion of vegetable oil to vegetable ghee or the vanaspati ghee. Is that clear? Okay, fine. Okay, here is the next question. Which of the following hydrocarbons undergo addition reactions? Options are provided here: C2H6, C3H8, C3H6, C2H2 and CH4. So what will be the answer for this question? Addition reaction, right? So we know that generally unsaturated hydrocarbons will be undergoing addition reaction, right? So here you need to identify which of them are the unsaturated hydrocarbons, are simply known as the alkenes or alkynes. So if I'm asking about the case of C2H6, whether it is saturated or unsaturated hydrocarbon, how we can define? C2H6. We have studied, right, in the case of C2H6, if you are taking general formula over here, you can see CnH2n plus 2, right? So you are taking n value over 2 over here, so it will be getting C2H6. This is the general formula of alkene. Alkene means this is a saturated hydrocarbon, right? Then what about the case of C3H8? So this is again 3, you are taking 3 over here, so 2 into 3, 6 plus 2, 8 over here. This is again alkene or saturated. Then what about the case of C3H6? C3H6. You can define the formula over here, right? CnH2n is the chemical formula over here. This is the formula of alkene, right? Double bonded hydrocarbon. That is unsaturated, right? This is the unsaturated hydrocarbon. What about the case of C2H2? C2H2 and CH4. Anyone? C2H2 means CnH2n minus 2, right? This is the chemical formula of the, or general formula of the alkyne. Alkyne means triple bonded carbon compound, triple bonded hydrocarbons. This is again unsaturated. And the last one, methane. We know that this is a single bonded carbon atom, so hydrocarbon. CH4. This is again alkane. So what will be our correct answers? We know that generally unsaturated hydrocarbons will undergo addition reaction. So which are the unsaturated compounds here? One is our alkene C3H6 and another one is our C2H2. Is there any confusion or doubt? Alkyne means triple bonded carbon, right? Alkyne means triple bonded carbon. Then alkyl means if you have the alkene compound. For example, if you are taking the CH4 molecule, right? We are deleting one hydrogen atom from the alkane part, then you will get the alkyl molecule over here, right? This is our methane. Then I am deleting one hydrogen atom from the methane, I will be getting the CH3 molecule. This is known as the methyl or simply alkyl group. Irish, is that clear now? Don't get confused over alkyne and the alkyl. Okay. Is that clear? Is there any confusion? Yes, 3 and 4, right? Here is the next question. How can ethanol and ethanoic acid can be differentiated on the basis of their physical and chemical properties? So we have already discussed many questions, right? I mean many properties based on the ethanol and ethanoic acid. Those are the functional groups, right? So they have the priority order over there. So they will be given the suffix over there, not as the prefix. I hope you understand. We have already discussed in the concept class also. So I hope you have idea about the ethanoic acid and ethanol. So we can just give few differentiation between the ethanol and ethanoic acid. Ethanol, we know that, right? That does not react with the sodium hydrogen carbonate or the sodium bicarbonate. It does not react with the sodium bicarbonate. While ethanoic acid will be treating with sodium bicarbonate to form corresponding salt and hydrogen. That will be giving bubbles and fizzes with hydrogen and hydrogen carbonate. I hope you remember. A proper equation is given in the textbook. Just refer from the reaction of ethanoic acid with carbonates and the bicarbonates. Then what about the case of smell? Ethanol, they will be having the pleasant fruity smell, right? They will be having the pleasant fruity smell and it will be having a burning taste. Then what about the case of ethanoic acid? Ethanoic acid means our acetic acid, right? Acetic acid means they smells like vinegar and taste will be around sour taste of the acids. Then what about the case of litmus test? Ethanol is no reaction, right? They are not considered as an acid or base, so they does not have any reaction with the litmus paper. But in the case of ethanoic acid, we know that, right? These are the acidic nature, so they will turn blue litmus to red. Reaction with carbonates or bicarbonate reaction with sodium. If they are asking about the chemical properties, you can take any of the chemical reactions. Like the reaction of sodium bicarbonate or the simply carbonates, right? And the reaction with alcohol and acid. These are the chemical reactions. And the smell, taste and the litmus test, these are the physical properties. Is that clear? Okay, here is our next question. Give a test that can be used to differentiate between saturated and unsaturated hydrocarbons. What will be the answer? We need to differentiate between alkenes or the alkenes, or alkanes or alkanes. Candle, how we can identify them using the candle? But there isn't any guarantee for the flame, right? Whether they are giving the blue flame or not. So proper chemical reaction is there known as the bromine water test. Okay. Bromine water test, right? So what is the procedure? It's like an experiment over here. Take two separate samples. One will be containing the saturated hydrocarbons like any of the alkane. Let's say any alkane. Then another test tube I am taking an unsaturated hydrocarbon. Unsaturated hydrocarbon like alkene or alkane. So what I am doing? I am adding a few drops of bromine water. This is the chemical having a brownish red color, right? Brownish red solution. Whenever I am adding to these two test tubes containing saturated and unsaturated hydrocarbons, what we are getting as the observation? The unsaturated hydrocarbons sample, the bromine water loses its color. Generally, they will be having the brownish red color. So when they are added to the unsaturated hydrocarbon, especially for our second test tube, they will be decolorized as the bromine water solution. Clear? This happens because the bromine adds across the double bond or the triple bond present in the unsaturated hydrocarbons. I hope you understand. Then what about these saturated hydrocarbons? That will not react with the bromine water solution, so the color will be remain same. Is that clear? So this is a basic reaction to identify or distinguish between saturated and unsaturated hydrocarbons. Clear? So we can't predict by using the flame test for the identification of saturated and unsaturated hydrocarbons. There will be some misconception will be there. Arush, I hope you understand now. Okay, this was the last question. So I think there is a doubt regarding the structure of the molecule, right? I think this 3,3-dimethyl propane, right? Arush, can you please repeat the question? 2,2-dimethyl propane or butane? So let's take an example of 2,2-dimethyl propane, right? How to draw the structure of this molecule? Let's see how to draw the structure of this molecule. So here, by using the flame test, we cannot easily predict the saturation and unsaturation over there. We are using the bromine water test only. I hope you understand. 2,2-dimethyl butane, right? Okay. So how to draw the structure? First, you need to identify the carbon chain. So here, word root is equal to but, right? But means total 4 carbon atoms is present. So I am drawing total 4 carbon atoms over here. Then, what is the substitutes given here? 2,2-dimethyl, right? It is already given as 2,2-dimethyl, which means in the second position of carbon, there will be 2 methyl groups are present. That is the meaning of dimethyl, right? 2,2-dimethyl. So we are drawing here, this is our second carbon. One CH3 is over here, one CH3 is over here, right? So this will be the branch over here. Now you need to balance the valency of carbon by adding hydrogen atoms. So what about here? One carbon is present, right? One bond is already present. So 3 will be occupied by the 3 hydrogen atoms. Then here it is already 4 valency is occupied. Then what about here? It will be 2 is already present. The remaining 2 will be added by 2 hydrogen atoms. Here again 1, then 3. Is that clear how we are drawing the line structure of the molecule by using the IUPAC name? Is there any doubt? Then what about the next compound? 2,3-dimethyl butane, right? 2,3 dimethyl butane. The only difference is that one of the methyl group is present in the third carbon atom of the butane. So same 4 carbon, right? 1, 2, 3, 4. This is our second carbon, 1 CH3 group is present. This is our third carbon, 1 CH3 group is present. The remaining valency is satisfied by the CH3 over here, right? So CH3, CH, again CH, CH3. Is there any doubt? Okay, where is 6 bonds is present? Arush, I didn't get your question. I think we are confused about the bond line structure, right? We will be focusing about the valency of carbon. We are considering only this carbon. So what about here? Carbon is already making one bond with the another neighboring carbon. So it is one bond. Then 3 hydrogen atoms. So total 4 valencies occupied there. I hope it is clear. We will be considering only carbon to identify the valency. I hope it is clear. That's why I am adding hydrogen over here in the case of second case. Is there any confusion? Our substitute is dimethyl, right? Dimethyl means methyl group is present as the substitute at the second and third position. I hope it is clear. Okay, we have already mentioned while discussing about the IUPAC naming of compound. For balancing valencies, we will be considering only carbon atom, right? So let's take an example over here. I'm just writing this again, right? Butane means 4 carbon atom, 1, 2, 3, 4, right? Then what about the substance given here? 2, 3 dimethyl. So this is my second carbon. This is the third carbon, right? Now the substance is balanced. Then what about the case of this carbon? Already 4 bonds will be, they have the valency of 4. So I am adding 1 bond over here. The remaining 3 will be added as 3 hydrogen atoms. Then what about the case of here? Already 3 bond is present, right? So I am adding 1 hydrogen over here. Then here again 1 hydrogen over here, right? So now it is. So this is the expanded structure formula and this will be the condensed formula. I hope it is clear now. Okay, fine. So this was that was the last question from the NCERT exercise for the chapter carbon and its compounds. So this chapter is very important. I'm repeating again in the case of IUPAC naming of the compounds along with the functional groups and the properties of ethanoic acid and ethanol are very important. You can expect more questions from the carbon and its compounds chapter. I know that this is a little bit difficult and it's a new topic for you. Valency of carbon is always 4. So you can try with many compounds to draw the structure of the molecule, then you will get a proper idea. Previous year questions will be there. You can refer from there. Try to practice more questions based on the IUPAC naming and the structure drawing. To draw the structure of carbon compounds. Clear? Okay, then that's all about from my side for today. I hope you understand. I hope you understand almost important topics from the chapter. And I'm repeating again, this chapter is very important. Just refer from the IUPAC naming of the compound. It will be very important for your examination point of view. I didn't get your question. In second carbon, already 3 bonds are there by CH3. We need to consider only carbon. I think we are already confused with the bond line structures, right? So once you just revise the chapter, then you will get a proper idea. If still not, you will. Okay, if still not, we will discuss it again. Okay, I will try to take one session based on the IUPAC naming and the structure drawing of the carbon compound, then it will be easy for you. Okay then, that's all about from my side for today. I hope you guys enjoyed the session. If you really like the session, hit the like button and subscribe our channel and share this particular session to your friends also. That will be really helpful for them also. And you want to join our Telegram channel to get the session PDF. CH3 will be considered as an alkyl group or the substituent, not as a part of the compound chain, I mean the longest chain. I hope you understand. So just revise the complete chapter, then you will get a proper idea. Maybe we will be continuing with the session. While taking the revision part for the carbon and its compound, then you will get a proper idea. Okay then, thank you so much all of you. See you in the next class. Bye bye.